Hi, my name is Carla. I am a registered nurse, and this lesson is going to be talking about how to calculate pediatric dosage calculations, but specifically we are going to be looking at safe dosage ranges. So let's take a look at the question. The doctor prescribed 250 milligrams for a 6-year-old patient, pediatric patient who has a fever. The doctor has prescribed acetaminophen, or Tylenol, to reduce her fever. The safe dosage range is 10 to 15 milligrams per kilogram of body weight every 4 to 6 hours. The patient weighs 44 pounds. The concentration of acetaminophen solution you have is 120 milligrams per 5 milliliters. Round your answers to the nearest tenth. Okay, so we have two questions that we need to address here. Question A says, calculate the safe dosage range of acetaminophen for the patient and determine if what the doctor prescribed is within that range. So for this question, we need to determine, first of all, if what the doctor prescribed, that 250 milligram, is that within the safe dosage range? And where do we figure out that information? Well, we look in the question to determine what safe dosage range is. Well, here it says safe dosage range is between 10 and 15 milligram per kilogram, meaning that it's not 10 to 15 milligrams alone. This is the amount, the concentration of medication per the patient's weight. So let me explain this as I answer the question. So let's do question A separately here. So what I mean is that I have to first determine the low range that is safe and the high range that is safe for my patient based off of their weight. Well, first of all, how much does my patient weigh? The patient weighs 44 pounds. They weigh 44 pounds, but they're saying that the safe dosage range is 10 to 15 milligrams per kilogram. So before I even solve anything, I'm going to convert those 44 pounds to kilograms. So we're going to do this like this. We're going to do 44 pounds, and let's convert that to kilograms. There's a few ways you can do it. You can do dimensional analysis, or you can just do the memorization of knowing that 1 kilogram is the same as 2.2 pounds. So we are going to divide that by 2.2 pounds. However you solve conversions is up to you, but 44 pounds divided by 2.2 is 20 kilograms. So far, all I know is that my patient weighs 20 kilograms. So what I could do is I can just cross this off and put 20 kilograms. Now, I can use that 10 to 15 milligram per kilogram to determine my low and my high safe ranges for my patient. Let's start figuring out the low. So the low is 10 and the high is 15. Let's start with 10. So I'm going to do 10 milligram per kilogram times my patient's weight, which is 20 kilograms. I can just put this over 1. It does not change its value. My kilograms cancel out, and that leaves me with 200 milligrams. So the low for my patient is 200 milligrams. That is the low. I'm going to write that here. Low. So the low safe range for my patient based off of her weight is 200 milligrams. Now let's figure out the high. I'm going to do the exact same thing, but now I'm going to plug in 15 milligrams into my formula. So now I'm going to do 15 milligrams. Where am I getting this 15 milligrams? From the question here. It says 10 to 15 milligrams. The high end is 15 milligrams. So 15 milligrams per kilogram times, again, my patient's weight, which we already calculated to be 20 kilograms. I can put it over 1, does not change its value. Now, kilograms cancels out. And now 20 times 15 is 300 milligrams. So 300 milligrams. So this is my high, meaning that for my patient's weight, the appropriate safe dosage should be between 200 milligrams and 300 milligrams. This is my safe range. Now I can go back to the question and see, did the doctor prescribe a concentration of medication that is within that safe range? So the doctor prescribed 250 milligrams. So is that between 200 and 300? Yes, it is. So the doctor prescribed a range that is safe. He's not underdosing and he's not overdosing my patient. Okay, so for question A, calculate the safe dosage range for the patient and determine if what the doctor prescribed is within that range. So I calculated the safe dosage range. That is my 200 milligram to 300 milligrams. And did the doctor prescribe a safe range? Yes, he did. He or she did. Okay, now let's look at the second part of the question. If the dose is within safe range, how many milliliters will the nurse administer? So far, I figured out the safe dosage range. Now, I figured out that the doctor prescribed 250 milligrams with this, which is within the safe dosage range. How do I figure out how many milliliters to administer? Well, this is where you can do either your D over H times Q formula, or you can do dimensional analysis. I'm going to show you the dimensional analysis method. Maybe in a different video, I can show you the D over H times Q method. So let's see. Prescribed. This is my D. Doctor prescribed 250 milligrams. What do I have available? Well, I have a concentration of acetaminophen solution that is 120 milligrams per 5 milliliters. I can do the D over H times Q, but I'm going to show you the dimensional analysis in this method. So for dimensional analysis, the way I like to teach is that first write equal and what you're trying to solve. What am I trying to solve? I am trying to find milliliters, right? Milliliters. I can put milliliters over 1. It does not change its value. This is just going to help me figure out what I need to put in my numerator and what I need to put in my denominator. So this is what I'm going to do. Equals milliliters. Do I see anything in my formula that gives me milliliters? Yes, I see the 5 milliliters. So I know with the dimensional analysis method that I need to have 5 milliliters in my numerator. So because its partner is that 120 milligrams, either the 5 milliliters goes on the top or on the bottom, and the 120 milligrams either goes on the top or the bottom. But like I said, we want it milliliters in the top in the numerator. So I'm going to write it like this. 5 milliliters over 120 milligrams, right? We're not separating that pair. We were just determining which one goes in the numerator and which one goes in the denominator. And now I need to cancel out these milligrams. How can I cancel out those milligrams? Well, I can use what the doctor prescribed, those 250 milligrams, and multiply. Remember, I am putting now milligrams in my numerator. Why is that? Because I am trying to cross cancel them out like this. If I were to have put 250 milligrams in my denominator, I would not have been able to cross cancel. Now I have milliliters as my only unit left over. Now I can actually calculate. So let's calculate. So 5 times 250 divided by 120, and I get 10.416. Yes, it was just double checking. So 10.416 milliliters. But remember, we always have to round our answers to the nearest tenth. So 10.416 milliliters would round to 10.4 milliliters. So this is the concentration of medication of Tylenol that I have to give my pediatric patient. Now I'm just going to double check a few things. I'm going to double check that nothing in the question that they gave me says per day or per dose, because I don't want misalignment of how often, the frequency, if it matches what I'm actually prescribing. So I'm going to reread the question, and I only see that every 4 to 6 hours, this is the amount I have to give. So this is per dose. It doesn't say anything else about per day. So my answer is final. I don't have to change anything else. So 10.4 milliliters is my final answer per dose that I have to give this pediatric patient. Okay, so hopefully that wasn't too difficult. Again, the goal with safe dosage ranges is that we have to figure out the low end and the high end. And we do that by seeing in the question what the milligram per kilogram safe dosage recommended dose is going to be. And then we use our patient's weight to determine, based off of their weight, the low amount of milligrams and the high amount of milligrams, because again, it's going to vary per patient weight. And for question B, all we did was a simple dosage calculation formula. Here specifically, I used dimensional analysis. You could have done the D over H times Q formula though. All right, let's look at another safe dosage range calculation. This one's going to be a little bit different. Okay, you're a nurse in a pediatric clinic and you have an 8-year-old who is prescribed an antibiotic, amoxicillin, for a sore throat. The doctor has prescribed a dose of 0.75 grams per dose. The safe dosage range is 460 milligrams per kilogram per day, divided into 2 equal doses. The patient weighs 30 kilograms. The concentration of amoxicillin suspension you have is 250 milligrams per 5 mLs. Round your answers to the nearest tenth. Again, so we're doing the same thing here. For question A, we are determining if we have a safe dose prescribed by the doctor. So we're going to do again the low and the high. And for question B, again, the same thing. We're going to figure out how many milliliters to give. So let's look at this question. Again, to find the safe dosage range, we need to find the lows and the highs. So here I see 40 milligram per kilogram per day. Here they added per day. So I'm going to be cautious to make sure that I am answering appropriately either per dose or per day. So calculate to see if the doctor prescribed a safe dose. Well, what did the doctor prescribe? He prescribed 0.75 grams per dose. So look at that, per day for the safe dosage range, per dose what the doctor prescribed. So we're going to have to make that work. Let's start doing the same thing that we did last time. Let's calculate the safe dosage for the patient based off of their weight. So this patient weighs 30 kilograms. I'm going to do the same thing. I'm going to find the low first. And again, the last question, if you looked at it, it had pounds and we converted it to kilograms so that it would match our safe dosage range. This one we already have 30 kilograms, so we don't even have to worry about that. It's done for us. So I'm going to plug it in. I'm going to do 30 kilograms times 40 milligrams per kilograms. So again, I can just put that 30 kilograms over 1 and my kilograms cancel out. And let's see, 30 times 40 is 1,200. So 1,200 milligrams. And this again, this is our low end. Now let's figure out our high end. We're going to do, one more thing, per day. Don't forget that. So this is 1,200 milligrams per day. Now let's figure out the high end per day. So we're going to do now 60 milligrams. Again, same thing. We're going to do 30 kilograms times 60 milligrams per kilogram. And again, this is per day. So per day. Let me separate this here. So this is going to be our high safe dosage range. So for this one, I can cancel out kilograms and I'm left with milligrams per day. And I purposely added per day. I should have done it in the last one on the low end, but let's continue forward. So per day. So 30 times 60, that's 1,800 milligrams per day. And this is our high end. So our safe dosage range for this patient based off of their weight is between 1,200 milligrams and 1,800 milligrams per day. And I keep I'm accentuating that per day because it is very important. What did the doctor prescribe? He prescribed per dose. He did not say per day, he said per dose. So how often are we giving this medication? Well, let's look at the question. It says divided into 2 equal doses, meaning that in a day you are giving 2 doses. So don't forget that. So the low is 1,200 milligrams per day. The high is 1,800 milligrams per day. The doctor prescribed 0.75 milligrams per dose. So if we're doing 2 doses a day, there's 2 things you can do. You can either divide the 1,200 and the 1,800 by 2, or I'm going to purposely do it the other way around so I don't have to do more work. I'm just going to multiply that 0.75 grams twice. Because remember, I said, the doctor said per dose, this is what I have to give, but I have to do that dose twice in one day. So what I'm going to do is I'm going to do 0.75 grams per dose. And I know that there's 2 doses in one day, so I'm going to multiply 2 doses per day. Because again, I need to cancel out doses, so I end up with day. So that is 0.75 times 2 is 1.5 grams. per day. 1.5 grams. So is that within the safe dosage? Well, if I do a conversion, I know that 1.5 grams is the same as 1,500 milligrams. So my doctor prescribed 1,500 milligrams per day. Is that within the safe dosage? Well, 1,200 is the low, 1,800 is the high, 1,500 fits right in. So we're good. The doctor did prescribe a safe dosage range for this patient. So yes, the doctor prescribed a safe dosage range. The safe dosage range is based off of this patient's weight between 1,200 milligrams and 1,800 milligrams per day. So far we have figured out question A. Now for question B, if the dose is within the safe range, how many milliliters will the nurse administer? We're going to do the same thing as the previous formula. You can do either D over H times Q or the dimensional analysis. How about in this one, I do the D over H times Q, just to mix things up a little bit. So your D over H times Q formula is going to say that your D is that 0.75 grams. Your H is going to be that 250 milligrams, and your Q is going to be that 5 milliliters. So if I were to plug this in, I would end up with 0.75 grams over using the D, whoops, let me write that over here. Using the D over H times Q formula. If I just plug that in, I have 0.75 grams, and then the H is 250 milligrams, and my Q is 5 milliliters. There's an issue here though. We don't have our units matching. Here I have grams and here I have milligrams. Those don't match. So I need to convert one of them. I am going to convert the grams just so I can get rid of the decimal. I don't really like having decimals when I calculate. So you can either do this, which is my preferred method, just to avoid a lot of this extra work, cross it off and write the new conversion. So 0.75 grams to milligrams. So how do we do that? We are going to multiply by 1,000. So 0.75 times 1,000, and that is 750 milligrams. So now my new formula is 750 milligrams divided by 250 milligrams times 5 milliliters. So what does that equal? Let's see. That equals 15 milliliters. So based off of the doctor's order and what I had available, my patient is going to receive 15 milliliters. Now, how often is that going to be? Per dose. Because remember, here in the D, it says per dose. So you have to really make sure that you're doing that appropriately. So every time I give this patient medication, it's going to be 15 milliliters. How many times will that be in a day? That's not in the question, but let's just talk about it. In a day, 15 milliliters, you do it twice. So an entire day, you would have given 30 milliliters. And that would have been within the safe dosage range as we calculated in question A. All right, so hopefully that wasn't too confusing. I can go into more depth into these pediatric safe dosage range calculations. I kind of mixed it up here. I added some dimensional analysis in the first question that we went over, and then I did the D over H times Q formula in the second question that we did. I did the same method for both of them ultimately because I would have received the same result. The method that you choose is really up to you. Personally, I prefer the dimensional analysis because you can cancel out and make sure that you have covered all of your steps. So if you would like me to do some more pediatric safe dosage range calculations, go ahead and message me in the messages or in the comments below, and I will see what I can do for you. As for now, if you have any more questions or you would like to see any more videos, go ahead and check out these videos that I'm going to be having for more math calculations, specifically for healthcare professions. Until next time.